Hello, my name is Juana Andreea Rușanu and I am a PhD student at Transylvania University of Brașov. In the next minutes, I will show you a live demonstration of my application, a simple brain-computer interface experimental prototype. That is based on the integration between the NeuroSky Mind of Mobile headset. This is the second edition that it was released in 2018 year. And a mobile robot that is based on the Raspberry Pi development board. In its structure, there are also two direct control motors, four wheels, one servo motor for changing the movement direction to the right or to the left, and a driver motor L298N that is based on the dual H bridge. As you can see, it is turned on. I developed two applications in Python programming languages that are running both on Raspberry Pi level and on my computer. So I will show you them. This is the Raspberry Pi code. In the beginning, there were imported the necessary libraries. Then there were added the necessary line of codes for pin assignments. I used output pins. This is the sequence of code for enabling the WebSockets-based wireless communication. Then I added some if instructions for switching between movement directions. Go forward, go backward, turn left and turn right. Also, it was implemented the stop command. At the end of the program, it was defined a function for listening for new clients or new threads. A Raspberry Pi plays the role of the server, while my computer has the role of client. I will run this program, so it will listening for new clients. And this is the Python application developed in a Spider development environment. In the beginning, the necessary functions were enabled. Then it was implemented the sequence for enabling the WebSocket wireless communication. As you can see, I called the library for enabling the communication with the NeuroSky Mindwave mobile headset. I have also added some instructions for creating the user interface. Then I worked with arrays, numerical arrays, to implement the algorithm necessary for voluntary eye blinks detection and counting. Also, I used the matplotlib library to display the graphical representation of time and amplitude variance of raw EEG signal. There were also added some if functions to switch between the movement directions. Okay, first of all, I will wear the headset. So I will attach it on my head. It contains one single sensor, this one. It should be placed on the forehead at the prefrontal lobe, and the reference or the ground that should be attached on the earlobe. The Raspberry Pi is already running. So I should start the Python application that runs on my computer. I will click on Run button. Now we wait for NeuroSky to be loaded. And now we can send the corresponding commands. So, one eye blink is for stop command. Two eye blinks determines the forward command. Three eye blinks are associated with the backward command. And four eye blinks are associated with the left command. And five eye blinks are linking with right command. Stop command. This is the stop command. And now we will perform some movement directions. The first one is the forward, go forward command. So, stop. Then go backward command. Stop. Then I will perform the turn left command. 4 eye blinks are necessary. This is the turn left command. Then the turn right command. 5 eye blinks. This is the turn right command. Then I will execute the go forward command. And I will perform 2 voluntary eye blinks. Stop. And go backward command. Then turn right command. This is the turn right command and stop command. So these were all the commands that can be sent to the mobile robot. Again, turn right command. Okay, and now I will perform go forward. Backward. Stop. At the same time with the execution of the voluntary eye blinks, all the performed commands were displayed in the console from Raspberry Pi. This is the remote desktop of Raspberry Pi. Also, the same commands are displayed here in the console of the Spider development environment. As you can see, right executed, stop executed, forward executed, backward executed, and so on. Also, there were acquired approximately 500 samples during 1 second. This is a quite difficult task because it means to set a time interval of almost 2 milliseconds between acquiring each raw EEG sample. And this task should be accomplished by all the computers. Turn left and turn right. 5 eye blinks. This was my application, a simple brain-computer interface